Today's video is going to be on factorising expressions. Okay, so our learning goals for today is to simplify expressions and solve mathematical problems using factorisation. Okay, so just a bit of a memory jogger back to when we did highest common factor. So that's a previous video, I think it was called number properties, if you want to check that one out as well. So remember, the highest common factor is a set of terms that is the largest factor that divides into each of the given numbers. So for instance, if we have on the board here, if we have here on the PowerPoint 15y and 21z, so we have to find the highest common factor. So what number can go into both 15y and 21z? So we've got to find the highest common factor. So y and z, they're both different pronumerals. So we know our highest common factor isn't going to be a pronumeral, it's just going to be a number. So we have to find the highest common factor of 15 and 21. So the factors of 15 are 1 and 15 and 3 and 5. Our factors are 21, 1, 21, 3 and 7. So you can see there our highest common factor is 3. So therefore highest common factor is 3. So highest common factor could be a number. If we looked at 10a and 20t, again, they both have different pronumerals there, so we know it's not going to be a pronumeral factor. So we're just looking for our highest common factor of 10 and 20, which is going to be 10. Our last one, though, we can see that they actually do have a pronumeral in common. So 18ac and 12c both have a c. So that means that we can also have this c, this pronumeral, as part of our highest common factor. We're also going to look at our numbers 18 and 12, and what is the highest common factor of 18 and 12? You can write it out if you need to, but obviously our highest common factor of those is going to be 6, and they've also got that pronumeral in common, which is c. So the highest common factor of 18ac and 12c would be 6c. So when it comes to highest common factors, they can be numbers, they can be pronumerals, or they can actually be both. And we need to keep that in mind because this will help us when we're working through these kinds of problems. Okay, so we're going to do some examples here of finding the highest common factor. So for our first one, we've got 4ab and 16b squared. We have to find the highest common factor. So obviously we're going to look for our numbers first. The highest common factor of 4 and 16 is going to be 4. Both of those can be divisible by 4. And then we're going to look at our pronumerals. So we've got ab and then we've got b squared. So both of those can be divided by b. So our highest common factor would be 4b. For our second one, we've got 3x and x squared and 4x. So we look at the numbers. So 3 is a prime number, x, well obviously there's a little imaginary 1 here, and 4. So there's no numbers that they have in common. So then we can look at our pronumerals. So we've got x, x squared, and x. So obviously our highest common factor is going to be x. For our last one, we've got 11, EFG, and 5G. Again, looking at our numbers, they don't have anything in common except for 1, so our highest common factor would be 1. Looking at our pronumerals, and good, we have one there, so G. So our answer there would be G. That would be our highest common factor. Okay, so now that we've got the hang of highest common factors, we can actually use this to factorise expressions. So there's a few steps when we factorise. So the first thing we're going to do when we're factorising expressions is to find the highest common factor of the terms. Next, we're going to write the highest common factor outside the brackets and then rewrite the expression inside the brackets. And we're also going to divide each of those terms by our highest common factor. Then we're going to solve that and leave that result in a bracket, and that's going to be our answer. Once we've got our answer, we can actually check whether it's correct or not by expanding it back and seeing if we get what we started with. So I'll do the example and it'll probably become a lot more clear. So the first thing we're going to do is find our highest common factor of 10y and 15x. So when it comes to the numbers there, our highest common factor is going to be 5. Looking at our pronumerals, we don't have anything in common. So our highest common factor is 5. So we've done that. First step, find the highest common factor. Done. 2, we're going to write the highest common factor outside the brackets and then rewrite the expression inside the brackets. And we're going to divide each of those terms by our highest common factor. So 10 divided by 5 is going to leave us with 2. So this side's going to be 2y. Take 15 divided by 5 will leave us with 3x. So that would be our answer there. So we factorised it and we've got an answer of 5 multiplied by 2y take 3x. As I said, we need to check it, and the way we check it is by expanding. So we'll just draw a line down the middle here, come over here, and we'll check our answer. So checking our answer. So 5 multiplied by 2y take 3x. So remember, when we're expanding, we're using our claw. So the 5 gets applied to everything inside the brackets. So 5 times 2y, 5 times 2 is 10, so we've got 10y. Positive 5 times negative 3 is going to be negative. 5 times 3 is 15x. Is that what we started with? Yes, so we know here then that our factorised answer was correct. Okay, so I've got a few examples here. Oh, I haven't numbered them. I haven't labelled them. So A, B, C, D. So we'll start off with A. So we have 14jn plus 10n. 14jn plus 10n. So remember, our first step is to find our highest common factor. So looking at our numbers, 14 and 10, what is the highest common factor to those? So our highest common factor of 14 and 10 will be 2. Then we're going to look at our pronumerals. Are there any pronumerals in common? Yes, they actually both have n. So our highest common factor would be 2n. So then we're going to write our 2n outside our brackets. Inside our brackets, we're going to rewrite each of these and divide them by our highest common factor. Okay, so equals 2n is going to stay at the front. So the n's will cancel out here. 14 divided by 2 will give us 7. So we've got 7j plus, our n's are going to cancel out again. 10 divided by 2 is going to give us 5. So our answer will be 2n multiplied by 7j plus 5. And remember, we need to check our answer. We're always going to check it to make sure we're correct. So I'm just going to rule a line here and write check, probably writing over my face there. So 2n in brackets 7j plus 5 using the claw. So we're going to apply that term out the front, multiply it by everything in the brackets. 2n times 7j. So 2 times 7 is 14. Jn. Remember, we're just putting our terms in alphabetical order. It's just the way we do it. It doesn't mean it's wrong if you do it the other way. It's just normally we write them in alphabetical order. So 2n times 5 is 10n. Is that what we started with? So we can check what we started, what we finished. Yep. So this means our factorised answer here must be correct. Okay, I'm going to clear the screen and we're going to do the next one. So 24g plus 20gj. So then we're going to try and find our highest common factor of 20 and 24. So 20 and 24, our highest common factor, what is it going to be? What's that, 4? 4 is our highest common factor. And then we're going to look at our pronumerals. Do we have anything in common? Yes, we do. They both have a g. Again, we're writing 4g outside our brackets. Inside the brackets, we're going to rewrite our terms and divide them by our highest common factor. And then we can simplify. So the g's are going to cancel. 24 divided by 4 is going to give us 6. The g is going to cancel. 20 divided by 4 is going to give us 5. So on this side, we've got 4g outside our brackets. Inside the brackets, we're left with 6 plus 5j. And again, we're going to check our answer. We're always going to check. I know it takes time, but you can ensure that your answer is correct if you expand your brackets back out. So 4g, 6 plus 5j, using the claw to apply it to everything inside. 4 times 6 is going to leave us 24g plus 5j times 4g, 20gj. Is that what we started with? Yes, good, correct. So we know our answer is correct. Clear that off. We'll do our third example. So we've got 28u take 42bu. Okay, so our highest common factor here. So our highest common factor of 28 and 42 is going to be 7. And looking at our pronumerals, we've got a u. So we're going to do our usual steps. Highest common factor at the front, rewrite our expression, dividing each of the terms by our highest common factor by 7u. So 7u, u's will cancel. So 28 divided by 7 is 4. U's will cancel. 42 divided by 7 is 6. So on this side we're left with 4. Take 6b. And that's our answer. But we always check, and we're going to expand that back out to make sure we got the correct answer. So using our claw, we're going to apply it to everything. 7 times 4 is 28u. Take 7 times 6 is going to give us 42bu. And that's what we started with, so we know our answer is correct. Now, lucky last, we've got 21p, take 6c. So our highest common factor of 21 and 6 is going to be 3, and we don't have any pronumerals in common, so it's just going to be 3 outside the brackets. 21p divided by 3, take 6c divided by 3. Remember to keep your equal signs. So 21 divided by 3 is 7, so we've got 7p, take 6 divided by 3 is 2c. And always check, so make sure that answer is correct. So 7p take 2c. We're going to use the claw to apply our term out the front to everything inside the brackets. So 3 times 7 is 21 with our p. 2 times 3 is 6 with our c. So 21p, 6c, that's what we had. Excellent. So we know that that's correct. So that is our lesson on factorization. So remember, we're always going to factorize using those same steps. Find the highest common factor, write the highest common factor at the front of the brackets, and then divide each term inside the brackets by the highest common factor, write our answer out. And don't forget our crucial last step, checking. So now that we've factorized, what we're going to do is we're going to expand it to make sure we're correct. So it is time consuming, but make sure you do it because you'll be able to pick up any mistakes you've made, especially if you're in a test. You can straight away find out if you've got the correct answer or not. The other thing I'd like to point out is the way I've set this out. So you can see here I've gone down the page and I've put equal signs at each stage. So I've written my question at the top, I've written the highest common factor, and then below that with equal signs I've done each of the steps, and I've kind of checked off to the side. Now always work down the page. It's easier for me to read. When you're writing across the page it gets all muddled up and it's hard to follow. It's also hard for you to follow and see where you're up to. Okay, so that's what we have for factorization. As always, if you need any help, make sure you do come and ask me.